Okay, so today we're going to be looking at 8.5, which is all about distance and applying what we know about the coordinate plane to different distances.
There are some measurements, such as temperature, where negative numbers have meaning. There are other measurements where negative numbers are meaningless. Distance is an example of a measurement that is always non-negative. Recall that absolute value measures the distance a number is from 0 on a number line. Absolute value is never negative. Distance cannot be measured in negative units.
So we've talked a little bit about how absolute value or distance can never be negative. Example, if you're driving your car to work, okay, or to school, it might be 2 miles. And when you drive back home, it's still going to be those 2 miles. It's not that you're going backwards. Distance is never negative. Okay, it's always positive.
It's a good thing for me that X, Y, and Z are all in the same vertical line here. Makes getting down so much easier.
Okay, so when we look at this, they want to know what is the distance between X and Y, and then Y to Z. So we know coordinates. Well, it looks like each of these lines represents 2. They go by 2s. 2, 4, 6, 8, 2, 4, 6, 8. So that being said, we know that Y would be at 3, 6, and Z or X would be at 3, 12. So what they're going to have you do is notice how they're in a straight line. That's really helpful for us because what we can do is take this and say, okay, well, if Y is going to be at, hold on, let me get this over. If Y is going to be at 3, 6, and 12 is at 3, or X is at 3, 12, well, I know they're in a straight line, so I don't really need to think about that 3, okay? But from 12 to 6, 12 minus 6 is 6, so I know that will be 6 units. And Z is going to be at 3, negative 2. Well, how many points are in between 6 and negative 2? Well, if you count with me, we'll have 6 to 5, 4, 3, 2, 1, 0, negative 1, and negative 2. So that being said, there will be 8 numbers between Y and Z.
Point X is at 3, 12 on the graph. Point Y is at 3, 6 on the graph. Each of the points has the same X coordinate, so find the distance between the Y coordinates. Part A. Find the distance between point X and point Y. The absolute value of 12 equals 12. So the point 3, 12 is 12 units from the x-axis. The absolute value of 6 equals 6. So the point 3, 6 is 6 units from the x-axis. Since the points are on the same side of the x-axis, subtract the distances. The absolute value of 12 minus the absolute value of 6 equals 6 units. The distance between point X and point Y is 6 units. Point Y is at 3, 6 on the graph. Point Z is at 3, negative 2 on the graph. Part B. Find the distance between point Y and point Z. The absolute value of 6 equals 6. So the point 3, 6 is 6 units from the x-axis. The absolute value of negative 2 equals 2. So the point 3, negative 2 is 2 units from the x-axis. Since the points are on different sides of the x-axis, add the distances. The absolute value of 6 plus the absolute value of negative 2 equals 8 units. The distance between point Y and point Z is 8 units.
So they want to know what is the distance between the points 4, 2, and 4, -2. So for this one, go ahead and write this in your notes with me. You are going to need to circle, I like to circle, okay, what's common here? Well, I have both numbers start with a 4, so that must mean I really need to pay attention to these second numbers. So I'll have the absolute value of 2 plus the absolute value of -2. Well, I know the absolute value of 2 is 2, and the absolute value of -2 is +2, and 2 plus 2 gives me my answer of 4. So let's go ahead and see if that's our answer. Okay, and they're saying that the absolute value of 2 plus the absolute value of -2 is equal to 4 units away from each other. The distance between 4, 2 and 4, -2 must be 4 units.
In previous lessons, we used negative integers to represent positions relative to a defined zero, such as sea level. That's not what you're doing here. Here, you're measuring the distance traveled. So even though the x-coordinates are decreasing, the distance will be positive. Gotta go. That's my train.
For this one, it says, your cousin rides the subway to work. His trip is shown on the coordinate plane. Each grid line represents one block. What is the distance between the start and station 1? And then what is the distance between station 1 and the end? So what I'm going to do is go through and find my coordinates. So for start, well, baby crawls before it walks, so that's 10. Okay, and it goes up, well, 2's here, so it goes up 3. Okay, station 1, baby crawls before it walks, so 6. And that's also at 3. Okay, and then over here we have -4, and we go up 3. So we know the 3's are all common. So they want to know how far do they go from the start to station 1. Well, I know that start is at 10, and station 1 is right here. So they're going to go 1, 2, 3, 4 blocks to get from the start to station 1. Okay, then what is the distance between station 1 and the end? So here I need to add my 6, or the absolute value of 6, plus the absolute value of -4, and I find that from station 1 to the end, that'll be 10 blocks. Okay, but then if they were to ask me how long in total was your commute, well, if this was 1, 2, 3, 4 blocks, and from station 1 to the end was 10, I know that 10 plus 4 equals 14. So my total travel would be 14 blocks. Let's go on to part 2.
What is the distance between the points -3, 2, and 2, 2?
So I would like for you to try this one on your own. Obviously, you're going to have to look at this -3 and the 2, because the 2 is the same in both of the y points for both coordinates. Go ahead and pause this video, write your answer, show your work, and I'll check this in your notes. And I am going on to part 3.
A city planner is using a coordinate plane to plan a new city park. The 4 corners of a rectangular dog park will be located at A, -3, 1, B, -3, 8, C, 5, 8, and D, 5, 1. What is the area of the dog park?
So when you look at this, they're going to want you to go through and plot each point. So go ahead and pause the video and plot each point for me, A, B, C, and D. So I learned for this one, the points are all going to be where they're located on this coordinate plane. So they want to know, what is the area of the dog park? So what they did is they said, okay, so here's our points. The area of the rectangle is going to be equal to the length times the width. So you need to find the dimensions by finding the sides. So they go ahead and they look at B, and they find that -3 plus 5 is equal to 8. So they found that -3, or the absolute value of -3 plus the absolute value of 5 is 8, which means this must be 8 blocks from B to C. Well, if BC is 8 blocks, I know these two dots will also be 8 blocks. Then they go through here and they say, okay, well, the absolute value of 8 minus the absolute value of 1 is 7. So this length is 7, which means this length is also 7. So if I have to do 8 times 7, what's my area? Okay, well, 8 times 7 is 56. So the dog park has an area of 56 units.
A right triangle has its vertices at -3, 4, -3, 7, and 5, 4. What is the area of the triangle? Use the formula A equals 1/2 times B times H, where B is the base of the triangle and H is the height.
So go ahead and draw a right triangle with me, just like this. And I know that, this will be -3, 7. This point right down here would be -3, 4. And this point would be 5, 4. So go ahead and find the vertices of this, find the area, and here are your possible solutions. When you are done, go ahead and turn your packet in for me in the Math A or Math B bin, depending on which class you're on, and then you may go ahead and start your homework.